Hi, my name is Stephanie Greenberg, and today I'll be presenting covidQR, which is my semester project for CS 426 Internet of Things. I'll begin with an introduction, which includes my motivation for creating this project and my project topic. As we all know, the COVID-19 pandemic began at the end of 2019, and by 2020 it reached many countries all around the world and severely impacted those countries affected by it. In response to the pandemic, many countries have developed contact tracing programs to prevent the spread of the virus. Contact tracing is used to track people who have tested positive, including the locations they visited and the people they've seen, in order to warn others who may have been in contact with them. Some countries have even developed their own COVID-19 contact tracing apps, with different countries adapting different technologies. Several countries and US states, including Austria, Germany, Japan, Australia, and Singapore, have created apps that utilize a new Bluetooth technology developed by Google and Apple that can detect all people within 6 feet. New York and New Jersey have also adopted an app called COVID Alert NY, which uses this new Bluetooth technology. Other countries have implemented other types of contact tracing apps. For example, South Korea uses a system that broadcasts alerts about where and when exposure may have occurred. China, on the other hand, uses a QR code system that assigns everyone a unique QR code and requires people to scan the QR code when entering public places. The QR codes are also different colors, indicating whether a person is at risk for coronavirus or not, as you can see in the picture on the right. The US, however, has not adopted a widespread contact tracing app like other countries such as China and South Korea. This motivated me to create my app, covidQR. covidQR is a contact tracing Android app that is inspired by the contact tracing apps in South Korea and China. It combines exposure alerts like those used in South Korea with QR codes like those used in China. Each user of the app is assigned a unique QR code, and this QR code is scanned every time they enter a public place such as a restaurant, train station, or store. The app also provides functionality for businesses to scan these QR codes. If someone tests positive, they will indicate that on the app, and the app will notify anyone who has possibly been exposed to that person. Next, I will discuss my system design and implementation. As I mentioned previously, the app contains two interfaces. One interface is for users who are just normal everyday people, and I refer to them as customers. When they log into the app, they will be navigated to a user landing page which displays their uniquely generated QR code that they can use to scan when they enter a public place. There's also a button on the user landing page that allows a customer to indicate if they have tested positive for coronavirus, and by pressing this button, they will trigger an action that will alert all other people who are potentially exposed. The other side of the app is a business interface, which mostly just acts as a QR code reader to get the user's ID every time they enter the business, and it also alerts the business by telling them if a customer should be permitted entry or not based on whether they've tested positive for coronavirus. For creating my app, I used a few different software and tools. I used Thunkable X for designing the user interface and for programming the app's functionality. For authenticating users when they enter their username and password and try to log in, I used Firebase authentication. For a backend database, I used Firebase Real-Time Database, which is a cloud-based database, and I used it to store user information, including customer and business information. I also used the coqr API, which is used to uniquely generate the QR code for each user. In order to send push notifications to users who may have been potentially exposed, I used OneSignal, which is a push notification service. In order to test my app, because I don't have an Android and I wanted to use multiple devices because in the real world there would be multiple people using this app, I used two different Android emulators, BlueStacks and Nox App Player, for testing my app. Every time a customer or a business creates an account on the app, Firebase authentication assigns them a user ID that is unique, which is used to identify them in the database, and also a database entry is created for them. As you can see here on the right side, the top level branch of the database is called app users, and that branch contains all of the users of the app, both customers and businesses. The information stored about them will vary depending on whether they are a business or a user or a customer. And as you can see, on the left side is an example of a business's entry in the database. It stores a list of the customers who have visited, as well as some information about them. On the right side, you can see an example of a customer entry, which contains some different information and locations visited. As you can see, the customer list on the left contains the user ID on the right, and the locations visited list on the right contains the business ID on the left. What that means is that the customer on the right has visited the business on the left. In order to generate a unique QR code for every user, I used the covidQR API. The API takes an argument that specifies the text to be encoded within the QR code. In the case of my app, I encoded each user's unique ID, which was generated by Firebase. So that way, when the business scans a customer's QR code, they will get that customer's unique user ID and will be able to get access to their information in the database and update the database accordingly. The app uses OneSignal push notification service to send push notifications to users who may have potentially been exposed. Once a customer indicates that they have tested positive in the app will go through all of the locations that customer has been to. It will then go through all the users who have been to that location and alert all of them. This will alert anyone who was possibly exposed to the virus and prevent the spread. In order to send push notifications to the specified users, the app sends a post request to OneSignal API, and the body of the request contains all of the users who should be sent a push notification. In this slide, you can see the code in Thunkable for the process that I mentioned previously. When someone tests positive, it will get the list of locations that person has visited. It will then loop through every location, and for all locations, it will get the list of customers who have visited that location. And then for each customer who has visited that location, it will get their Play ID, which is used by OneSignal to identify a device. This will create a list of the customers that should be notified and their devices, which will have a notification sent to them. Here you can see the Thunkable code for actually sending push notifications to the users in the list that we generated in the previous code. What it does is send a post request to the OneSignal REST API. The body of the post request contains a field called Include Player IDs, which takes the list of the player IDs which correspond to the devices of the users that should be notified that they've potentially been exposed to COVID-19. And the contents field is just the message that should be sent in the push notification to all of these users in this list. Now I will demonstrate how my app works. For my demonstration, I have a physical Android device and 3 emulators on my laptop. So now I'm going to create a customer account on one of the emulators on my laptop. As you can see in the database, I've already created a business. You can see the type is business of the entry in the database. So now I'm just creating an account. The email is customer3@gmail.com. And you'll see that the database updated and it added a unique user ID for the email customer3@gmail.com. And right now they haven't visited any locations, so there's nothing in there. And if you look at Firebase authentication, you'll see the users that have been created so far. So there's business@gmail.com, customer3@gmail.com, and customer1 from another emulator that I created an account on. I've already gone ahead and created the customer accounts on 2 other emulators, so now I'm just going to scan the QR codes for those customers. So you'll see I scanned one customer and then the other, and this represents them coming to a store and the store scanning their QR code. And now I'm just scanning the third customer's QR code. So yeah, you can see that entry was permitted for all of them because none of them have reported that they tested positive for COVID. And now if we look in the database, we'll see that all the information for the 3 customers and the fact that they visited the business will be added to the database. So you can see there are 3 customers with emails customer 1 at gmail.com, customer 2, and customer 3. And if you look at the locations visited for this customer, it has the ID of the business. And same for this customer, it has the ID of the business that scanned its QR code. So let's say that one of these 3 customers tested positive. So I'm clicking the button and you can see that it says, thanks for letting us know. We'll alert anyone who may be exposed. And then on one of the phones, which has the app open, it says you may have been exposed. And then in the other app, it shows an alert. So if, a push notification. So if you're in the app, it will give you an alert. And if you're not in the app, it will give you a push notification so that you can see the exposure alert even if you don't have the app open. And that's all for my app presentation. I hope you enjoyed it, and thank you for your time.